So I'm going to be talking a little bit today about dimensional analysis. Dimensional analysis is a system that you can use for doing a large number of conversions relatively easy and painlessly. Some old chemistry teachers used to call this the factor label method. It's really the same thing, so if you've heard of one, it's the same thing as the other one. Rather than go deeply into how it works or why it works, I'm just going to jump in and show you how to do it. So work these along with me. I'm going to take a look at number one. What it wants me to do is it wants me to convert 5,400 inches into miles. Now, at this point, those of you who have some kind of sense of the world around you or some kind of sense of math, you've probably already got figured out, well, I just convert this to that, and then convert that number to that, convert that number to that. So in some cases, it's going to be faster just to use the math that you already know. The reason I'm showing you the system I'm showing you today is that the system I'm showing you today takes the guesswork out of it, because sometimes you might kind of forget, well, am I supposed to multiply or am I supposed to divide to go between meters and kilometers? Or, where was I again? What does this number actually mean? Dimensional analysis takes all the guesswork out of it and makes it super, super simple. The first step of dimensional analysis is take whatever you're given. You're going to put it over 1. You're going to turn it into a fraction. So looking here at problem number 1, I've got 5,400 inches, and I'm wanting to change it into miles. So I'm going to start by taking those 5,400 inches. I'm going to put it over 1. That doesn't change the value. All that does is turn it into a fraction. Okay? Because anything divided by 1 is still going to be whatever it was when you started. Now, in this next step, what I'm going to do now is I'm going to put a little multiplication sign. I'm going to draw another line to make another fraction there. This next fraction here, what I'm going to look for is I'm going to look to see what is the unit of this first step. Whatever the unit is, in this case it's inches. If it's on top in this step, it's going to be on the bottom in the next step. Now what I'm going to do is I'm going to choose some kind of a conversion factor. And instead of me telling you what that is, how about somebody tell me, what do you know about inches?
12 in a foot.
There's 12 in a foot. That's exactly right. So in other words, I could say that there's 12 inches in 1 foot. Okay? Now, if you come up here, it says don't forget, you put what you want over what you've got. What you've got, what I had, was inches, and it went to the bottom on this step. Now, what I want to get goes on the top. But wait, I don't want to get feet. I want to get miles, right? So since I'm not where I want to get yet, I'm just going to lay down another multiplication sign, draw myself another fraction line. This time, since feet are on top, they're going to go down to the bottom in the next step. Does anybody happen to know how many feet are in a mile?
5,280.
5,280. And if you didn't know that, it's up here in the little table that they give you on the paper. So I'm going to put 5,280 feet. Feet was on top. Now feet is on the bottom. I'm going to put 1 mile on top. Since miles is what I want, I know that I've got it set up. So I'm going to put little equals right here. Now, I'm going to do a couple of things here. First of all, I'm going to clean this up a little bit. I'm going to clean this up because I know something about division. I know in division that if I take anything divided by itself, let's say that I take 7 divided by 7, what does that equal? 1. Okay. What about 100 divided by 100?
1.
Okay. What about turnip divided by turnip? Turnip divided by turnip is not turnip. It's 1. You just told me anything divided by itself is 1, so why would that be different? It's not. So in other words, if I have something and I'm dividing it by itself, they cancel each other out and they both turn into ones, right? Now, what if I've got two different units that aren't the same thing? Like, say, for instance, what if I take miles divided by hours? That doesn't equal 1. What does that equal?
Miles per hour.
Exactly right. So see, they're both still there. It's still miles divided by hours, but now I've got a new unit that has both of them in it. Okay? So I'm going to come back to the problem I'm working on here, and I'm going to see that I've got everything that is on the numerators, everything on top is being divided by everything on the bottom right here. So, in other words, I've got inches being divided by inches. And you know anything divided by itself is equal to what? 1. So check it out. Inches divided by inches means I get to cancel those out and turn them into ones. How about feet divided by feet? Same thing. You get to cancel them out. They turn into ones. What's the only unit I have left at this point? Miles, right? And what am I trying to get? I'm trying to get miles. So, that's the first thing I'm going to do to clean it up. The second thing has to do with how I'm going to put this in my calculator. Now, I know that your math teachers have told you before, when you're multiplying lines of fractions, you want to multiply all your numerators and get an answer. Then you want to multiply all your denominators and get an answer. Then you do the product of the top one divided by the product of the bottom one. I'm going to show you that you don't have to do that. You're making extra work for yourself. What I'm going to do is I'm going to live by this very simple rule. Anytime that I've got a line of fractions, I'm going to multiply everything that's on the top, and I'm going to divide by everything that's on the bottom. And I can plug it into my calculator just like that. Okay? So take a look here real quick. Let me get the calculator. Can you all see that all right? Kind of, sort of. Zoom out. Okay. So, I'm going to plug in 5,400 times 1 times 1. Now, let's be honest with ourselves. Do I really have to type in times 1 times 1?
No.
Because if you multiply something times 1, does it do anything to it?
No.
It doesn't change it. So really what I mean is I'm going to look for everything that's not a 1, and I'm going to multiply by the ones that are on top. So I'm going to do 5,400 times 1 times 1, so I'm done with the top. Now I'm going to divide by everything on the bottom that's not a 1. So divided by 1, I don't have to put that in. But there's a 12, and there's a 5,280. So I'm going to do divided by 12, and I'm going to go divided by 5,280. Now I haven't hit equals yet. All I've done is I've put in top number divided by the 2 on the bottom, and it spits this out at me. Okay, 0.085227273. I'm sure it would probably go on. Now, what were we talking about last week that told us how we should round numbers? Anybody remember? It rhymes with big twigs.
Big thing.
Sig figs, fantastic. Okay, so following the rules of sig figs, if this was a measured number, then I would just count how many sig figs are in it, which is 2, right?
Right.
And so my answer, I would only have to round out to 2 sig figs, which would be the 8 and the 5. So my answer here is going to be 0.085. The only unit I have left is miles. And I'm done. Now, for you doubters in here who are like, you can't just change the rules of math. You're not even a math teacher. Who the heck do you think you are? Let me show you what happens if you do it the old-fashioned way. If I multiply everything on top, it's 5,400 times 1 times 1, which means that the numerators come to 5,400. If I multiply everything on the bottom, it's 1 times 12 times 5,280. I'm not going to try and do that in my head. So let's just do 12 times 5280. And I get 63,360. And so if I do this top one divided by that one, so I'm going to do 5,400 divided by my answer. Hey, look what I get. It's the same thing. So trust me, you're saving yourself some time if you just remember, multiply everything on top, divide by each and everything on bottom. Okay? The only time you use the word times is when you're doing these up here. Otherwise, it's divided by. And the math will work out. Now, doing a really mean thing. I'm throwing math at you on a Monday morning, and I'm not giving you an awful lot of context here. So, this is an excellent time to ask a question, and the questions might be something like, Mr. King, where did you get XYZ step? Or, Mr. King, what's the point of this anyway? I'm open to any and all questions, so who's got one? Rain? Okay, like the process or the reason? The process? Yeah, we're going to do lots of examples. Don't worry about that. Okay. Anybody else have questions? All right. I don't believe you that you don't have questions, so we are going to work several more. But again, you probably could have figured out, well, hey, if I want to change inches into feet, I'm dividing by 12. And if I want to change feet into miles, I'm dividing by 5280. Okay? I'm not throwing this at you because I think you can't do math. But if you take a look at how this is set up, if you follow these rules, if you put what you're given over 1, and then you make sure that whatever unit is here goes to the bottom in the next step, you will never have to think, do I divide this or do I multiply this? Because it's all set up for you just like that. Okay? Because in the problem, I'm given inches. And whatever I'm given goes on top. And you always put what you're given over 1. Okay? Yes, Josh?
How we turn weeks into seconds.
How you turn weeks into seconds? We'll get there. We will get there. Let's go take a look at number 2. Right? Problem number 2, we've got 16 weeks. We need to change it into seconds. So we're going to start with the quantity that they give us, which here is 16 weeks. And what are we going to do with those 16 weeks? Okay. Now, I think it's extremely important that I mention you can't just put the numbers and leave the units off. The units tell you what goes where. You have to write the units, or this all falls apart. There's way too much to keep track of, and y'all are good, but you're not that good. Okay? So, let's talk about what we know about weeks. I don't know how many seconds are in a week, but I do know, say again, Rain, there's 7 days in a week, so I know that 1 week equals 7 days. So what's going to go on the bottom here? 1 week. Okay? I know weeks goes down here because weeks was on top here. Whatever's on top goes to the bottom of the next step. I'm going to go 7 days on top. Now, if I was to divide weeks by weeks at this point, they'd cancel each other out, and I'd be left with days. I don't need days. I need seconds, right? You know how many seconds are in a day? I don't. Ah, but you do know. 1 day is 24 hours, right? Okay. Now, again, I knew that days went down here in the denominator because it was up here in the numerator on the last step. So days divided by days, those are going to cancel out. I don't need hours, I need seconds. Does anyone happen to know how many seconds are in an hour?
60.
No, and no, and no. Okay? Now, if you don't know how many seconds are in an hour, what do you know?
60.
You know it's got 60 minutes, right?
Right.
Okay. So, if you don't happen to know that there's 3,600 seconds in an hour, then you can just go from hours. Okay? We've got 1 hour equals 60 minutes. I'm not trying to get minutes, I'm trying to get seconds, so I need one more step. And I know that 1 minute is 60 seconds. So hours will cancel hours. Minutes will cancel minutes. What am I left with?
16 weeks. 16.
Okay, well I'm left with a lot of numbers actually. And if you look here, if our next step is to multiply everything on top and divide everything on the bottom, what do you notice about everything on the bottom on this one?
It's 1.
It's all ones. So I'm not even going to have to divide. I just have to multiply these 5 numbers together. And that's easy, right? So it's just going to be 16 times times 7 times 24 times 60 times 60. I get a big honking number. Okay, I get 9.6 million and change. Okay? Now, if we were worried about sig figs here, then I would say, hey, 16 weeks would be my measured number. That's what I'm starting with. But I'm going to assume if we're talking weeks, this is probably a counted number, so I'm not even going to worry about it being significant. I'm just going to assume the whole thing's significant, which means I've got to report the whole thing. So the whole thing is 9,676, 800. My unit is seconds, and I'm done. If I wanted to put this in scientific notation, which was another thing we talked about last week, how would I do that? Okay, well, I'm not moving a zero, I'm moving a decimal. Okay, where does it go? Between the 9 and the 6, right? So it's going to be, remember, scientific notation is digit, point, digit, digit. So it's going to be 9.6 what? Are you sure it's 7? It's 8. Why is it 8 and not 7? You're rounding up because of that next number is a 6. So 9.68 times 10. Is this number greater or less than 1? So it's going to be a positive exponent since it's greater. How many times did I move that decimal? I went 1, 2, 3, 4, 5, 6. So times 10 to the 6th. It's pretty much the same thing. I know it's not an exact number, but when you're talking millions of seconds, you know, what's a few 10,000? Statistically, it's not much when we're talking seconds. And that's dimensional analysis. So let's do a thing. Rather than ask everybody, hey, do you get this, or are there any questions? Because nobody ever gives a straight answer to that. What I'm going to do is I'm going to have you show me with your hand. Okay? So here's how this works. Okay? Well, 1 means, who am I? Why am I here? I want my mommy. 2 means I'm a little lost, but I kind of get a few things. And on up to 5 is, I totally get this. I'm bored. Can we go faster, please? So everybody show me a hand. Show me with your fingers how well you personally feel like you're getting this. 3, 2, 1, go. Okay, we got a 3, we got a 3, we got a wiggly 3. Got a 5, we got a 3, maybe a 4 over there. Okay, I'm seeing 3s. I can work with 3s, that's fine. And we will work some more of these. But I want to move on to what the next thing is, because if it was just something this easy, then it wouldn't be a big deal. But go ahead and skip page 2 and take a look at page 3. And it's everybody's favorite thing about math, word problems, right? All right. So we've got 4 word problems here on this page. I will let you, the class, decide which one would you like me to work for you first. Okay, and it doesn't mean it's the only one. It means which one do you want first, 11, 12, 13, or 14? Daniel, what do you think? Daniel's liking 13. Everybody else? Okay, here to vote for 11. 14. Okay. I'm going to go rock, paper, scissors, 13 then. Okay. So let's look at 13. Every 3 times I clean my bedroom, my mother makes me an apple pie. How nice. I clean my bedroom 9 times. How many apple pies does she owe me? Okay. Now, that is a very easy problem. I'm not going to work that one. Okay? But if I was to work this one, okay, then what number am I starting with? What is the quantity that I'm given here? I'm not given 3. Aha! Tricked you. It's not that easy. So, what I want to do is I want to look, because they do give me several numbers in here, I want to find my conversion factors. I want to know what equals what. So according to this, 3 times I clean it is equal to 1 pi. Agree? Okay? And that's really the only conversion factor they give me. So what else did they give me there that's not a conversion factor? 9 times. So I would actually start this one with 9 times. Put it over 1. So what is my factor? 3 times equals an apple pie, right? So what goes on the bottom? 3 times or 1 pie? 1 pie goes on the bottom?
3 times.
3 times goes on the bottom? How do you know which one's right?
Because 3 times is on the top.
If times is on the top up here, times has to be down here on the bottom. So 3 times equals 1 pie. Times cancels times. So 9 times 1 divided by 1 divided by 3. Or in other words, 9 divided by 3 means 3 pies. That's easy. That's a one-step problem. Let's look at one that's not quite so easy. Do you want to look at 11 is a little more complicated than I want to go straight to. So do you want to do 12 or 14?
14.
Okay, who votes 12? Raise your hand. Who votes 14? Raise your hand. Who's scared of what other people think? Raise your hand. All right, let's look at 14. I appreciate your honesty. In my chemistry class, 28 students are each given 3 pens. If there are 8 pens in one package, priced at $188 per package, what's the total cost of giving away pens? Let's figure out what's a conversion factor and what we're actually supposed to start with. So, what is a conversion factor? Okay, so 3 pens for every 1 student, right? That's conversion factor. What's another one? Okay, 8 pens are in 1 package. Anything else? It's also $1.88 per package. So I could also say that 8 pens are equal to $1.88, right? I could jump straight to that because all 3 of those are equal to each other. So what's the only thing in that problem that does not have an equivalence? 28 students. So that tells me that's what I'm going to be starting with. I'm going to draw this a little bit different this time because you sometimes see it drawn a little bit different. I'm going to still start with 28 students. Still going to put it over 1. But this time instead of putting an X, I'm just going to draw a vertical line. It means the same thing. So I've got students on top. What can I convert students to according to my problem? Pens, okay? So 1 student equals 3 pens. What goes on top? 3 what? 3 pens. How do I know that students goes on bottom? Good. Whatever was on top goes down to the bottom. So that tells me pens. I'm trying to find total cost. So I don't stop with pens. So I'm going to draw myself another line. Go on to my next one. So, can I get from pens to something else? What can I get to? I can go from pens to package, or I can go straight from pens to cash, right? Okay? So 8 pens equals $1.88. So what goes on top? $1.88. $1.88 goes over 8 pens, which I got from the problem here. So let's cancel stuff. Students divided by students, boom, roasted. Pens divided by pens, boom, roasted. I'm left with dollars, which is what I want, right? So now, we're going to go to our very last thing. Remember, you multiply everything on top, you divide by everything on bottom. So I'm going to do power on. I'm going to turn the calculator on. It works better that way. So I'm going to go 28 times 3 times 1.88. What's the only thing I divide by here? 8 divided by 8. If I do that all as one operation, it tells me it's going to cost me $19.74. Now that's before tax, I think, probably. But I'm not worried about taxes right now. Maybe it's tax-free, because I'm doing tax-free weekend. Anyway, that's dimensional analysis. And that's all there is to it. Show me fingers. How are you feeling about this? Between 1 and 5, be honest. Don't make your fingers lie. Okay, we got some solid 4s now. Numbers are going up. Good deal. Still on a 3, that is fine. Okay, on 4. Okay, Daniel, you got fingers? Got 4, and one of them's kind of creaky. Okay, that's fine. Emily, you got fingers? Okay, that's fine. All right, so let's do another one. Okay, you want to look at 12, or would you like to go ahead and tackle 11? the heebie-jeebies. Now we know that that's not a thing. So let's cross out heebie-jeebies. And let's put COVID. Grandma's got a cure for COVID. So here's how this works. She says, COVID-19. You take 1 drop for every 10 pounds of body weight per day divided in 4 doses until the heebie-jeebies are gone. How many drops do you take per dose? So we are looking for drops per dose. So when I'm done with this one, my units at the end should be drops over dose. Okay? Now let's go find some factors here. What are some conversion factors they give me in the problem?
1 drop per.
Okay, 1 drop for every 10 pounds. Okay? Anything else? Yeah, 4 doses. Now they don't go out there and say, like what's being divided into doses. They just say we're taking this and dividing it into 4 doses. So that's going to come into play in just a minute. It looks a little bit different than what we've done, but not too much. Okay, so the question is, what do I start with? Nope. What's something the problem doesn't give you that you have to know to start this? Your body weight. Now, I'm not going to make this about your body weight. If you want to do your own body weight, that's really fine. If you want to know how to cure your own Rona, but Rona. Okay. So I'm just going to use my body weight as an example. Okay. I'm decently close to 210 pounds. So I'm going to start off with 210 pounds. And again, I'm going to put it over 1. Okay. If you want to use your own body weight, feel free, because every step from here on forward is going to be different depending on what you start with. It's going to be the same, actually. So where do I go from pounds according to what they tell me up here? 1 drop equals 10 pounds. Okay, so what goes on the bottom? Pounds. So 10 pounds goes on the bottom. 1 drop goes on top. So at this point, if I did pounds divided by pounds, those would cancel and I'd have drops. Well, I don't want to just have drops. I want to have drops per dose, right? So here is where we're going to fudge the system just a little bit. It says we're going to take this and divide it into 4 doses. So if I'm dividing by 4 doses, where are my 4 doses going to go? On top or on bottom? On bottom, because you divide by on the bottom. So I'm just going to put 4 doses down here. And I'm just going to put a 1 there. You know, it's not a 1 flat. It's just whatever is being divided by 4 doses. So at this point, I will have drops per doses. So I do 210 divided by 10 divided by 4, which is going to give me something like 5.25 drops per dose. Now, since this is real-world math, you know, aside from the heebie-jeebies, or whatever Grandma's given me in the dropper bottle, let's talk about how practically you do this. You can't do 1/4 of a drop, right? So I could do one of 2 things. What's one way that I could give myself this medicine? I could just go 5. I could round down to 5 drops a dose, which would be closer to 20 a day instead of 21 a day, and that's fine. Or maybe my first dose of the day, I could do 6 and then do 5 for the other ones. Okay? You know, so there's still, you know, the nice thing about real-world math is there's not a single right answer to how you then take those numbers and run with them. But that's the answer to that one. If you're 210 pounds, if you've got a different body weight, of course, then you would have a slightly different answer to things. But I don't care if you do your own on this. It is just practice. So, does anyone have any questions about how this works? This is a great place for them. Show me fingers. How you feeling? 5, 3, 4, 4, 4.5. Okay, 4 again. All right. So there's still some room for improvement. What I'm going to do at this point is I'm going to go ahead. I'm going to tell you what I'd like you working on now, and then I'll kill the video. Look at the last page. You need to make a quick correction on the last page. Go down to number 17, and where it says what you found in number 8, cross out the 8 and put a 16. Otherwise, this doesn't make sense. What I'm going to have you work on is number 16 followed by number 17. Okay, so 16 will be the first one. You're going to work it, and I will let you in just a minute. Do you want to work it by yourself? Great. If you want to find someone to kind of scoot a desk closer to and work with, someone, then that's fine. Let me give you a pro tip real quick on 16 before you get started. 16 is actually asking two questions. It's asking how many dollars did you actually find, and it's also asking how much did it weigh in pounds. So there's two different problems there. So you can set up a dimensional analysis for the first one. You actually don't have to because it's fairly easy math. It's one step. But you're definitely going to want to set one up for the second one. One more thing you're going to want to know. 2.2 pounds equals 1 kilogram. 1 kilogram is also equal to 1,000 grams. Okay? So use that information however you'd like to use that information. Okay? At this time, find a partner or don't and work on 16. If you get done before everybody else, go ahead and work on 17. I'll wander around, and if you've got a question, I would be happy to see if I can help out.